We are currently amidst a plastic crisis right now. Plastics have become such an integral part of our daily lives that we do not know a world without it. We use plastics for everything, ranging from packaging our fresh produce, vegetables, and fruits to throwing our waste away in the trash bin. Without plastics, our world would not look how it is today. The World Economic Forum estimates that by 2050, there will be more plastic in the oceans than fish in terms of weight. The problem with plastics is that it is not biodegradable, and it will persist in our environment for hundreds of years. Unfortunately, we do not have hundreds of years. We need materials that can biodegrade and be recycled into our natural ecosystem and do not persist in our environment, contaminating the oceans, the soil, and animals living inside it. That is why we came up with the idea of mycelium. There are already many companies like Ecovative that are looking at mycelium-based materials to replace plastic packaging. And they already are providing companies such as Dell with mycelium-based packaging material. Why mycelium could be a potential replacement for plastics is the fact that it is very strong and durable. Mycelium is like the stem part of a fungi, and as it grows, it spreads out with fungal hyphae, which act like a mesh or glue, sticking all the substrates together. Furthermore, one of the main components of mycelium is chitin, which is the main component in crab shells or the exoskeletons of insects. So mycelium has a huge potential for the future, and there are many aspects of it that we investigated.
For the experiment, we're going to use oyster mushroom and shiitake mushroom.
So this is the mycelium that we have, and what we've done is we've grown it in a substrate, and then we've put it in an oven to bake it, which kills all the mycelium, and which will allow us to utilize the mycelium bricks in different ways, such as using them as packaging, like Dell is doing, or using it as material that is anti-fire resistant, or also shock absorbent. So mycelium has the potential to be used in all sorts of industries and can change the way we view plastics and can make plastic-like materials renewable and biodegradable, which will be very beneficial to our society moving forward into the future.
So far, we only did the technical research about the mycelium material. First, the density of the material. The table shown indicates the density of the mycelium blocks suggested by various research papers. In average, mycelium blocks are expected to have about 200 to 300 kg per meter cubed. Compared to the density of water, which is 1000 kg per meter cubed, this is a low density. Since the material is currently being used as an insulator, the specific heat capacity of the mycelium block is expected to be high. A research paper provided that the mycelium had specific heat capacity of 7.4 to 10.2 kJ per kilogram per Kelvin. And its hardness is expected to be higher than styrofoam but lower than strong plastics. And according to the research, it is predicted to be oil-proof and fire-resistant. We are expecting it to have high acoustic insulation due to its porous nature, so there are a lot of empty spaces or air holes inside the mycelium material, which enables it to have higher damping capacity, which links to the acoustic insulation, so it can damp the vibration easily. And we are also going to experiment how mycelium blocks react to shocks, how it reacts to stress, and how it deforms in order to investigate its physical property. And we will also look at its chemical properties. We'll see whether it reacts with weak, strong base or acid. Also, we're trying to dissolve mycelium blocks in some solutions where chitin dissolves because chitin is the main component of mycelium. Overall, mycelium materials have the capacity to substitute lightweight plastic materials such as styrofoam, polyurethane, and EPS foam that are used frequently in sandwich panels, insulation, and packaging. It would have an advantage over these materials because of its biodegradability, so it does not persist in the environment and cause harm. And it's also resistant to fire, not like the other lightweight plastic materials.